The following video is a breakdown of my Lab 2 relational and non-relational databases for ENGO 451. This assignment was completed in VS Code using Anaconda and Python. Let us begin. Here we have the assignment file that was given. Everything prior to starting the actual questions was run and completed. I did not use Google Colab, so that was not necessary. Could have been deleted completely. Within the data processing, I executed every single line. The output was satisfactory. We can see durations, start dates, end dates, start stations, end stations, and bike numbers and member types. Scrolling down, we continue all of the code that was given. We can see every single one has been executed and has not given an error. There is an actual output, thank God. Continuing down to the actual assignment, this says there are a total of 11 questions. There are actually only 10. And let's get started into question 1, which appears in this cell here. So before starting, the URI, username and password for Neo4j, had to be established to establish a connection for all of the nodes and relationships. Scrolling down a little bit to question 1, we see here that we want to add the relationship between A, trip and the bike, and B, the trip and the member. The following lines of code allow us to create relationships between a trip that was taken and the bike that was used, as well as the trip that was taken and the type of member who took said trip. Using trip ID as the source and the row member type, we can create a relationship that can tell us what type of member took what trip. The second part does the same thing, except it creates a relationship between the trip ID and the bike that was ridden. Now for question 2, the code here will take a list and turn it into individual rows so that each element can be worked on separately, similar to AutoCAD when using the explode tool on a polyline, which probably isn't the best example, but it helps me understand it better. Once the batch or list of dictionaries is unwound, we create nodes for each piece of information to easily work with later. This just runs it all in one go. It might be a little fragile, but it worked pretty well for me so far, so I kept it as is. And that's just this section here. Now to question 3. We need to write a cipher query to create edges in Neo4j. Now it's nearly identical. However, now we are working with the edges. The unwind function breaks the list of edge data into individual rows. Match source finds the starting node of the edge, match target finds the ending node of the edge, and create builds the relationship between the two. So now we can move on to question 4. And once this was executed, we can see here a visualization of the nodes and relationships within Neo4j, which has a limit of 1,000 each within that desktop program. Now moving on to the cell here, which is number of nodes and number of edges. We can see there are 14,566 nodes and 44,416 edges. This is good. This shows us that there is actually something that has been created. It's not completely empty. Now we can move on to when it inserts into the graph. Data was successfully inserted into Neo4j. Perfect. And now we are moving on to questions 4 to 10. So, For question 4, we are looking for the top 10 most popular start stations for bike trips. Easy enough. With match, we find all the trip and start station relationships, then use return to make groups by station and number of trips that started at said station. Finally, we just need to put it into descending order to find the top 10. Question 5 is nearly the same thing with the ending station instead of the starting station. So if we scroll down here, we can see the output. There are start stations given in this column here and the number of trips per station that started there. Oddly enough, for question 5, the top station to start at and end at have the exact same number of trip count. Moving on to question 6 here. We need to find what is the average duration of bike trips by member type. First, we need to match and create the relationship between the trip and whether the bikes were ridden by a member or just a casual civilian. The return is a simple line of code to establish the average duration. Choosing descending order or ascending order doesn't really matter here since there are only 2 options for member type. And we can see here that the average duration for a casual member is significantly higher than that of a member, or rather all members. Moving to question 7, we need to find how many unique bikes were used in this data set. Each and every question almost starts exactly the same way, with creating the relationship needed to answer the question. Here it is simply determining how many different bikes were used. Each trip has a specific bike associated with it, and using the distinct function, we eliminate duplicates. So we can see that there are 2,946 unique bikes that were used. Now on to question 8. How many trips were taken by each member type? Now, almost the exact same as average duration in terms of what needs to be created in terms of a relationship, except now we are looking for the total trips taken per member. This all just takes some getting used to getting everything in the correct order. So once you have the pattern down, it's very simple just to not copy and paste, but modify slightly to get the correct results. And here we can see the member total trips exceed the casual total trips, which is a little bit strange considering the average duration for casual members is higher than that of regular members. Now moving to question 9. This next one is nearly identical to the previous question. However, we want to know the top 10 most bikes used. So instead of ridden by, we used by and the node type bike. Using count T means we are counting how many trips per bike, and we want this in descending order to get the top 10. So we can see here that W21072 has the highest with 19 trips. Finally, for question 10. Personally, I found this one more challenging in terms of trying to wrap my head around all the different relationships that need to be made. I started with using the most popular bike as the random bike variable. I don't have a reason, I was just curious what the output would be, and it didn't disappoint. With the specific bike established, I created the relationship between the trip node and used bike, which I set to W21072. Then a relationship between the trip node and the starting station needed to be created, along with the trip node and ending station. Once all the groundwork was complete in this section here, which is simple, almost identical to all the other previous questions, we can get the start date for each trip, the start station and end station, as well as the duration of each trip. Now, the first time I did this, I accidentally typed start_date instead of start, capital D for date, and it showed absolutely no data, as we can see here. So under trip start, see a lot of none, which wasn't ideal. Unfortunately, this was, well, I guess more fortunately, this was an easy typo mistake right here. Now with that fixed, I was able to produce all of the trip start dates with their respective start stations, end stations, and duration of each trip.